export this DR. So see here, so whatever the file I told you, CFG file, whenever I save a DR from SIGA, CFG file, .dat file, .gg4 file, .inf file, .xml, all those files has been exported here. Okay, out of which CFG and DAT are mandatory for analyzing a DR. Together only you can able to open the DR, and other things are auxiliary files. Maybe it will give you additional information. That's it. So let me open this CFG file in Notepad. So how to do analysis without SIGA? You can do a fault analysis even without a SIGA. How to do an analysis? You can open in Notepad directly. So in CFG file, I told you that it will be having the configuration data, right? So here, what is the project file and what is the folder, where the folder file is existing, and 30 is total number of channels. How many channels are there? Okay. And out of 30, 23 are analog channel here, and 7 are digital channel. So in this DR configured device, you have 30 channels recorded, out of which 23 are analog channels and 7 are digital channels. Okay. What are the 23 analog channels which are given below? IL1, IL2, IL3, 3I0, all those things. Okay. And digital channels follows after 23 analog channels. And in digital channels, you can see first signal is flag last configure, and this is the address number, and last 0 represent that it is currently low in this DR. Similarly for relay trip and everything, because this is one of the manual trigger DR, all the digital channels are low currently, so that's why it is representing as 0 on the end. At the time of DR, when it is triggered. If it is relay trip happened by that time, the relay trip will be high, it will be 1. So this, which one, sir? This is address. Analog signals only you will be getting the CT ratio and PT ratio. In case if it is a CT channel, IL1 here, this IL1 is your CT channel. Okay. In the last you can see 2 into e power 2, which means 200, and secondary 1 into e power 0, which is 1. 200 by 1 is your CT ratio, primary CT ratio here.
So at the last, S is written for all current and voltage. S is written at the last.
At the last,
S is written here.
Values are secondary values.
Secondary values.
P
Okay.
and S, secondary value
Okay.
and primary value. Okay, so these are the details you will be finding in .cfg file.
There's
Okay,
the
so let
frequency.
me open the DAT file. See, in this DAT file, what and all you are getting here?
So this will open in Notepad itself.
You can open in Notepad.
Oh.
Generally, don't give you any option to open.
Ah.
You can open in Notepad. Yes. Sir, see, these are the samples. During first sample, the values recorded are 0, -1, -1, -2. These are the analog channels, and the final one is these are the digital channels. Okay, all the digital channels are 0 for every sample because it is not high at any point of time. And these are the analog channel. The first value, which is -1, which is your IL1, and -2 is your IL2, and then IL3. Yes. This -1 is there, right? -1, -2, -1 -4, -2. These are the analog channel value at the sample, first sample. And second sample, when the second sample has been taken, initially first sample has been took at a 0th value, and second sample has been took in 1250. Okay, just 100 milliseconds later, 125 milliseconds. Okay, so every samples, how many number of samples have been recorded over here? All those samples will be shown here. This D80 file will not have any other data apart from the sample data.
1000 indicates 1000 microseconds. That is 1 millisecond, 2 millisecond, 3 millisecond.
Okay, sir. So, shall we move to next? DG4.
Content of the DAC file also depends on the recorded time.
Yes, sir.
Content of the DAC file.
The other one is blue. Okay. So these two cursors are used to find the relative timing or relative threshold differences between the time. For example, between the time of tripping and pickup. So you can keep the red cursor on pickup value, and you can move the blue cursor on trip value. And here in this table, you will find the relative timing and which signal you want to measure. For example, all the analog signals will be available over here. If you click the analog signal, at that moment, what is the current threshold value which is measured in this DR, which is recorded in this DR. Okay. This is for cursor 1, orange cursor, and this is for cursor 2.
But how we will in this time scale, how will we know that which will the moment when the delay has picked up?
So you will find out in DR channel, right? If you are configuring digital channel for DR, pickup digital
We
channel.
have to synchronize.
Yeah, we have to synchronize these things. Okay, and the timing here which is 0. 0 generally based on your settings in your relay. Start with pickup or save with pickup. Because based on your settings. No, it is not fixed actually. You can move this cursor, you can find any values with this. Blue ones, those are two cursors which are available. You can, as per your flexibility, you'll be getting only one cursor. Okay, so go to time signal and keep the red cursor wherever you want to know all the values. Keep the cursor over there and click the table view. Corresponding values of all the analog channels will be reflected over here. Okay. But this view will be having only one cursor, and wherever you are keeping cursor in the time signals, that will be reflected. But if you want, you can move here. Yes, sir.
Harmonics are
I'll
also
explain.
known.
I'll explain.
So that the signal will be grouped. All analog signal will be grouped, current and voltage, and you can see the down. Then you can uncheck the signals also.
Just 2 bits.
And what is
No, it is really.
so if you want again, so just go here, new drawing. Then you can configure whatever signal you want, right?
We can delete this, or we can add a new. New.
You can assign the signal.
New is added. We'll add the signal. Insert signal.
Even you can group every signal to one diagram also. It's up to you.
Analog signal.
And when you save this
Digital
file,
signal.
when you save, it will be stored in the
Analog signal.
DG4 file. So DG for
Zone 1.
proprietary file. So that it will be used for your profile. And then you can use different profiles also. For example, each user wants to view in different point, right? So we can customize this and save us your user different profile.
Somebody will be familiar with by seeing those signals individually. Somebody may be familiar with grouping those signals. So you can, as per your familiarity, you can save, you can change and save only for you. Some other guy will come and open the tier and it will be open default format also. Okay, and in Hussain signals, Naveen has showed you, right, those channels. So whatever the analog DRs, analog channels which have been recorded in this device, all those things will be there. Okay, so only thing is that you need to configure. It will not be visible immediately. For example, the frequency value will not be there in front of you immediately. but you can assign it from there.
So how you get in the routing matrix, right? Like that, if you don't want other signal, just go on and check.
And what are the signal you need? You can check. Doesn't have those. This is a triggered DR, so that's why it is showing 7. Till then it will be that. Okay. At the moment, see, this is also variable. This is not fixed. By moving the cursor, so at the moment of the cursor has been kept in minus 144 milliseconds. So at that moment, what is the first harmonic, second harmonic, third harmonic, those details. If you are moving the cursor, then based on the timing, what are all the frequencies recorded, those things will be visible. Okay. So next to harmonics, we have a circle diagram. Circle diagram here, generally it will be, if you are having pole slip DR, if you are having more characteristics, then you will get to know those details. And after this, you will be having vector diagram. Vector diagram R, Y, B, and neutral phases. What is the vector range? So those vector range will be there. Here in this vector diagram also, you will be getting two cursors. So if you want to analyze the phase angle between your current and voltage, you can view it through vector diagram. And in circle diagram, so even in distance protection, if you are having a distance characteristics, those characteristics will be available over here. And in case of power swing, if you are having a power swing DR, out of step DR, you will get to know where the swing came, how it entered into your zone, and how it went back. All those things can be visible in this circle diagram. Yeah? No, that is vector. Vector is not only 2. R, Y, B are neutral. All 4 values will be there. Okay, and as well as the voltage values. And next to vector diagram, we have time signal. So, and this one is assign signal. Assign signal, if you want to assign any voltage or analog signals, how frequency you will be assigning. This is a shortcut key for assign signal. And then major thing would be the primary and secondary value. See, here you will find the primary value and secondary value. So whatever it is showing in this table, you want to know the primary value, then you can get the primary value. And if you click this second one, then you will be getting the secondary value. Okay, here you will be having instantaneous value and RMS values. Separate options are there. You can view this DR either in instantaneous value as well as in RMS value.
That's value in second.
Yes.
It's 6.1, 0.1,
X-axis is milliamps here. See, it is milliamps here. Below is time second, and this is milliamps. Since this is current channel, you got in milliamps. In case the current is more, then it automatically shift to ampere and kiloamps. Similarly, for voltage, you will be having voltage channel and as well as the kiloamps, kilovolt.